Hi everyone, I welcome you all in tutorial 4 of my ETABS software training series. Till now, we have discussed how to model a structure, define material properties, define and assign sections, modeling of staircase, and step load calculations. If you haven't watched my previous tutorials, don't worry, I will paste a link in video description so you can access to my previous tutorials. If you are new to my channel, please subscribe to it and press the bell icon so you can be notified on my next uploads. In this tutorial, I will discuss about two topics. First one is how to assign dead loads, live loads onto your structure. And the second topic is how to read the loads from code books. This is very important. For this case, I will refer to American or ASCE code, Indian standards commonly known as IS code, UBC 1997 code, and building code of Pakistan. I am considering these codes because they are most commonly taught in our institutes and used in the design offices. So let's begin. So I've already opened the ETABS model. So before assigning the loads, let's look at some theory of the loads and classifications. As you can see in this slide, the loads are classified into two types. First one is gravity loads which acts vertically downward, and lateral loads which acts in horizontal manner onto the structure. So the gravity loads are further classified into two types. Number one is dead load. The examples of dead loads include self-weight of structure or the weight of any permanent fixture in the structure. The example for the live loads are wind effects on the structure, seismic effects, any retained material against a structure, which could be water or earth, temperature loads, vibration loads, and hydrostatic pressures. So in ETABS, you don't have to apply self-weight of structure. ETABS calculates it by its own. However, you need to apply any other dead loads and live loads which acts onto your structure. Now the question is, how much weight or magnitude of weight we should apply? To answer this question, we need to refer code books. As I told earlier, I will refer 4 codes just to teach how to read the codes and how to extract the information of load data from the code books. And finally, we will use the load data from ASCE code and use in our model. So let's start from the Indian codes. In order to refer the dead loads value, we will refer to IS 875 part 1. For live loads, we will refer to IS 875 part 2. And for seismic loads, we will take help from IS 1893 part 1. So let's open the codebook IS 875 part 1 for the dead loads. So as I told you before, we need not to apply the self-weight of structure, but we have to apply permanent fixed objects on the structure. So the permanent fixed objects in dead load category are mortar screeding, surface finished, etc. The quick way to search the desired data from the codebook is to press Ctrl F from your keyboard and type the T word. So we need the weight of mortar screeding and tiles. So let's find out. So just type mortar and click next several times. So as you can see, there are several data available: gypsum mortar, lime mortar. We have to search for mortar screeding. So here, for mortar screeding of 10 mm thickness, the weight is 0.21 kilonewton per meter square. Okay, now go back to your ETABS model, switch to the plan mode. In order to apply the dead loads, click all story from the drop down list. Either you select slab one by one, or you go to select menu, from select click select, then select object type and find out floors, then click select floor. This is a quick way to Select all the slabs which are assigned into your model. As you can see, all the slabs in our model are selected. So in order to assign the load, go to Assign menu, click Shell Loads. As we are going to apply uniform loads, so click Uniform, choose Dead Load, and the value is 0.21 kilonewton per meter square. 0.21, so it comes out to be 4.46 pound per feet square. Click OK. As you can see, the dead load is applied on all the slabs which are modeled in our structure. After that, we have to go and search for tile loads. Type tile. You can also assign marble or any other tile type or floor finishes you are going to use into your model. So tile, so let's search for clay floor tiles. So for clay floor tiles, the value is 0.10 to 0.2. So we are choosing 0.2. So again, go to select menu. In order to assign the load, you have to select the object first. For selecting the object, go to the select menu, object type, floors. Select floors, click close, go to the assign menu, shell loads, click uniform. Now we have already 4.47 earlier, so we have to add to the existing load. So click add to the existing load, and the value of load was 0.2. Again 4.255. So ETABS by default added the previous value and the current value which we have entered. In similar way, let's refer to ASCE code in order to see minimum design loads which are associated with buildings and other structures. Since we are designing residential building, so go and find the weight of finishes. Type keyword finishes, click several times. As you can see, the load for floor finishes is written here, cement finish, which is 1.53, ceramic. In this way, you have to choose the value from this code book. For example, I am choosing cement finish of 25 mm, which is 2.5 centimeter. It is 1.53. So again, you have to go to your ETABS model, select for the object type, choose all the floor areas, go to assign menu, shell loads, uniform loads. So the value was 1.53 in the category of dead load. So 1.53 value was in kilonewton per meter square, but we have to put the value in pound per feet square. So divide this value by 0.047, so it comes out to be 32.55. Click OK. So in this way we can apply the dead load. Similarly, we need to search out for live loads. Refer to the code book again and type residential. Click next. C, apartment, C residential. So Various occupancy uses are written here. If you are designing office building, so you need to refer to this code book in order to see minimum design loads. See, for hospitals the various loads are written, for hotels, libraries. Since we are designing a residential building, so we have to look for residential. So uninhabitable attics without storage, and with uninhabitable attics without storage, as you can see in this picture, there is a pitched roof. So if it is uninhabitable, so the loads are 10. If it is habitable, so the load could be taken as 30. So all other areas except stairs, again we have to choose. A similar value was written in IS code. All other residential occupancies, private rooms and corridors serving them, again we have to choose 40 for these categories. For public rooms we have to choose 100 PSF. So for roofs we have to choose 20 PSF. Because we don't have a lot of movement of people and objects there, so that's why the load value is reduced to half compared to the loads at other floor levels. So in this way, again go to your ETA model. You have to select all the objects. Go to assign menu, shell loads, uniform loads. In the category of live loads, you have to apply 40. Click OK. So till now we have done with IS code and American code. Now let's refer to the Pakistan building codes to see what are the minimum design loads given in the Pakistan code. So let's look for the live loads. So since again we are going to type residential. Residential, for basic floor area we have to choose 40 PSF. For balconies we have to choose 60. For decks storage we have to choose 40 PSF for live loads. Similarly for UBC code, if you refer to UBC code, the values will be same as given in Pakistan. Building code. See. So if you refer to UBC code or Pakistan code, the values are almost identical. As you can see, for residential area, it is given 40, 60, 60. Only the table is reproduced in other format. Otherwise, the load values are the same. That's why I told you earlier the provision of building code of Pakistan are compatible with Uniform Building Code 1997. So in this way, we can choose the values of dead loads and live loads. We can put it in our model. So as I said, we will use ASCE code values in our model. So go to again select object type, select all floor areas, go to assign menu, shell loads, uniform loads. As we have seen from ASCE code, the values for dead load comes out to be 33 pound per feet square, so click OK. Similarly, we have to do the same for staircases. Assign shell loads, uniform 33. Okay, now we have to assign live loads. Assign shell loads, assign shell loads, uniform. Choose live loads from the down list. Type 40 and click OK. Choose the staircase area. Go to assign menu, shell load, uniform load. So the live load was 60. Now we have to also apply step loads on the staircase area. So for first flight, the staircase load was 22.19. For the second flight, the dead load was 32.27. Select the first flight, go to assign menu, shell loads, uniform, choose the dead load, click add to existing loads because we have to add the step loads into the existing value of dead load, which was 33. So the step load for first flight is 22.6. Click OK, close. Now select second flight, go to assign menu, shell loads, uniform, 30.27. Click OK. As we are done with dead loads and live loads, now we have to assign wall loads. In order to assign the wall loads, as we can see, the height of our floor is 12 feet and we have kept the depth of beam as 2 feet. So 6 inches will be in the slab, so the total height for wall will be 10.5 feet. Go to the plan mode. So our exterior walls are of 9 inches dimension and our interior walls are of 6 inches dimension, and height of the wall is 10.5 feet. How to assign the frame loads? First select all the exterior walls or exterior beams. So on these beams 9 inches walls will be resting. So go to assign menu. In order to assign the wall loads, we have to select frame loads, distributed loads. So wall load is also in the category of dead loads. So how to calculate the wall? As we know that our height of wall is 10.5 feet multiplied by, so density of wall, if I am considering cement concrete block, so the density will be 0.145 kip per feet cube, and our thickness of wall is 0.75 because our outer wall dimension is 9 inches. So the exterior load of wall is 1.141 kip per feet. So click OK. Now choose the interior walls. So the thickness of our interior wall are 6 inches. So go to the frame line, again go to distributed load. Now all the data will be same except the thickness of wall, so it will be 10.5 multiplied by 0.6, which is the width of wall, multiplied by 0.145. This is the density of cement concrete block. Click enter and click OK. Switch to the 3D mode. As you can see, we have successfully applied wall loads. Now we have to change the wall load at roof level because our parapet wall is of 3 feet. So go to the plan view, story 3, click OK. Choose one story from drop down list. Click the exterior wall. Select assign, frame line loads, distributed. So now the wall loads will be, the height of wall is 3 feet multiplied by density of cement concrete block multiplied by thickness of wall, which is 9 inches, 0.75 feet. 0.32, click OK. So at the roof level there will not be any interior wall. So select all the interior walls in order to remove the loads. Go to Assign menu, Frame Line Loads, Distributed Load, click Delete Existing Load. OK. Switch on to 3D mode. As we are done with assigning dead loads, live loads, and frame line loads considering the codal requirement we defined. In this tutorial, we have successfully assigned dead loads, live loads, frame loads using IS codes, ASCE codes, Pakistan building codes, and uniform building codes. So guys, this brings to the end of today's tutorial. If you find this tutorial useful, please do like and share. And if you have any doubt, you can comment in comment section. For upcoming tutorial videos, please do subscribe my channel and don't forget to press the bell icon so you can be notified on my next uploads. Thank you and have a nice day.